Good afternoon. Welcome to Angular, JSON, and REST. Oh my. My name is Orion Correa. I work for InterSystems in our application services group. We do a lot of the internal applications used by InterSystems, such as CCR, cache download, our single sign-on, and a number of others. So a little background: about a year and a half ago, we started looking at alternate tech stacks for our front-end applications. And we considered some different options and ultimately ended up on AngularJS and Angular Material. We chose these because they will give us the tools we think that will help us to build applications going forward. There's lots of good options, but we're going to go with these. As a point of clarification, there's Angular 1 and Angular 2. Everything I'm showing you and talking about will be Angular 1. It's stable and more compatible with the Angular Material library, from what I understand. So I'm probably going to say Angular and just mean Angular 1 during this presentation. So over that last time, I've worked on a couple different projects using Angular, mentored a couple interns. In the meantime, Chris Stewart in the UK rewrote the TRC application into the new iService using this Angular and Material stack. And he wrote an article series on the developer community about that experience and how to get started on these applications. So I'll be presenting based on that material. It's an excellent series, and there's more information on everything there. So I highly encourage you all to go check that out. So this is the first presentation in a number that we're going to use the same Widgets Direct demo application. The code will be available later. We have it in a GitHub repo, and it will be public if it's not already, and there's a link to that. So I'm going to skip past Hello World and jump to kind of a first working example. For this project, we are the web developer of the Widgets Direct company, and we're a leader in selling all sorts of widgets, and we've been tasked with building a new website, and we're going to use Angular and Material to do this. So the pieces you need to get started are two CSP web applications. One has all of your Vue components, your JavaScript, your resources, everything else that you'd normally include in a website. And then you need a second CSP web application for your REST calls. And in that REST application, you will define a REST dispatch class which will handle all of your the routes that you can call or the URLs you can call to make your REST calls. So we're going to have /widgets direct and /widgets direct /rest for our two applications. After that, we actually want a UI, so we're going to have a landing page. We're going to name it welcome.csp. You can also have flat HTML files. For the purposes of what I'm doing, there's no difference. But we're going to use the CSP class here. And then we're going to have a JavaScript file to have our Angular and JavaScript and our controller code in there. So after we put those pieces together, we get something that looks a little like this. And I'm going to jump into Atelier. And show you some of this. So this is Atelier. It's our new IDE built on the Eclipse and has plugins for Git, which I'm going to make use of, as well as many other things. This left side is kind of your standard package explorer that you might see in Studio. I have a namespace, or I have an Atelier project called Widgets Direct that's connected to my namespace in Cache that all my code will live in. This is my Git repository that's connected to the repo on GitHub. I'm going to be jumping through different commits in there, which I've staged the different versions of code. So I'm going to jump through those and show you what it looks like at different points in time. And then this is obviously the viewer. So our first class is the dispatch class, which goes on our REST CSP application. And at the top, we define a set of routes. These are URLs we can call to call some method on the server. So we just have a basic /. So the path for this would be our server name, and then /widgets direct /rest, and then this :name means we're passing that as a parameter into the method that we're going to call, which in this case is called hello world. Also note that this is a get method, We'll come back to that later, but just to be aware of that. So when we send a request to that URL, it calls this class method hello world, and it's just going to make a dynamic object here and create a message with our name. That's where that parameter comes in, and then make 10 objects and number them 1 through 10. And then we're going to write that object back out to the client as the response. And we're using this %2JSON. So remember that. We're going to come back to that as well. And on our client side, we have our CSP. You've got your standard Angular NG app Widgets Direct up here. You've got your NG controller, the page controller. And then we have a repeat loop that just lists all the widgets that we're passing it over. And we've got the messages up in a toolbar at the top. You notice these aren't actually divs or things like that. These are material components. They have all of the styling included in the material library. So for this project, I don't think we write a single line of custom CSS. It's all inherited from the material library, which is why we're doing this. And here's our website. So we've got the banner up at the top. We've got a list of these widgets. You'll notice there's some highlighting here. This is the material design style guide that implemented in the material library. And this logo will not be there. I think it's checked in like stage 10, but it's just a link to a random little image. But we've got our list of widgets here, and we've got it somewhat formatted. So that's great. That was pretty easy. Didn't take much code. Oh, I did want to show you the controller. We're making our HTTP GET call to our URL, and then we set the message to our scope message and the widgets to our widgets. And then on the page, we're just displaying everything in that widgets array. So Angular Material is a client-side front-end library. It implements the Material Design Style Guide by Google. And there's great documentation on this, for this on their website. And we chose this because it saves you a ton of time writing custom CSS, and it lets your applications have the same look and feel, so it's easier for your users to understand it, and it's easier to maintain, and then it saves developer time so that we can focus on coding as opposed to designing, which some of you may be designers. Our team is developers, and we're good at coding. We're not as good at making things look nice and writing the custom CSS. And so we're going to spend time coding as opposing to making it all look pretty. So we're just going to use the kind of pretty much vanilla Angular Material styling. So we've got a view page, and that's great, just listing some widgets, but we want to make it a little better. We're going to add some filters. This is a feature of Angular. You pretty much get it for free when you're using Angular. And this is the code changes we've made. I think there's 4 lines of code or something. We add a couple properties to our controller, sort ascending, and widget filter text, which you don't see. We add an input for that text field. We add a button that toggles this sort ascending property. And then we append the filters to our repeat. So we have a filter on the text, and we have an order by on the sort. So really basic stuff. And let me actually do the next slide. We're also going to start using persistent data instead of our 1 through 10 widgets. So we have a widget class that we're going to connect to, and we're going to update our REST GET call to grab the data from that class. So how do we get the data from the class into a JSON object that we can read on the client? Well, this is where that %2JSON comes in. We're going to write a custom utility method called toJSON, and there's a system method called %2JSON. Our utility method is going to take the data from our class, open up an object, and put the fields or the properties we care about into a dynamic object. And then the %2JSON takes that dynamic object and converts it into a JSON formatted string that we can send back to the client. I know they're named the same. It makes sense to me because they work together in doing the same purpose, and the % one is the system. You can name your custom one whatever you want, but this is what makes sense to me, so this is what I've used here. So let's jump to our website. Oops. Let me load the next version of the code and synchronize. I'm pulling down the next commit from Git and updating the database there. And when I refresh, we've updated the color. I didn't show you that, but that's a simple change. And then we have a filter here. And we've got a bunch of widgets that there's a populate method that just creates some data for you. And so now we have this is connected to our persistent widget class, and it's pulling the data out of there. So I can go ahead and filter and say waterproof, and it pulls out these. I've got duplicates because I ran it twice, I think. And then I can also reorder these to swap the order, ascending or descending. So remember, we added those filters really easily, and then we wrote this to.json excuse me, to grab the persistent data and ship it to the client. And let's take a look at that. If I open this, we now have a cursor that's going through our widget class and just grabbing everything there. And then we come down, we open each widget, and we call to.json, which is our method, and we push it into an array, and then we write the whole object with %to.json. Let's see, our view page should not have needed to change for this. There is a widget class here now, and there is a populate class that just generates some data for us. So here we go. We've got persistent data, and we're pulling it onto the server. We've got our utility methods that will do that for us. So now we're going to start improving our code a little bit. We're going to separate out the page controller, which is handling that REST call from our from our initial JavaScript file, and we're going to separate those things out to make it easier to find things in the future and maintain and upgrade and improve things. So we're just going to separate those files. And when we do that, we copy it exactly, but we get this nice error in the browser console, which is not all that helpful when you look at it. If you kind of read through the escaped characters in this URL, you'll notice it says page controller, not a function, undefined. And the issue here is that we didn't include that new file in our view page, that JavaScript file. So this is just an example of how Angular errors might show up. Generally, the page will not render correctly, and you will get some sort of error in the browser console. So that's where you look for those sorts of things. It's not always super helpful, but it does tell you when something's wrong, and then you can go through your code and figure out what you might have done wrong. Okay. So we didn't become the worldwide leader in widgets for nothing. We don't have just plain widgets. We actually have accessorize for all our widgets. And now we want to include those on our website, naturally. So this is a new class. We're going to go through the same process. There is a relationship to our widgets class, and there's actually a link class in there that you'll see. But we're going to do the same thing. So we're going to write a to.json on that widget accessory, which will take the properties from that accessory class, put them into a dynamic object that we can then write to the client. We're going to include the array of accessories in our REST call as part of the JSON object that we're shipping off. And we're going to add something to the view page to display this data. So let me jump to the next stage. All right, so now we have this widget accessory class. It's got a bunch of properties. Here's our to.json. It's just grabbing each property stick it in a dynamic object with the same name, and then we return that object. And in this case, we don't actually change our dispatch class at all. We're going to handle this in our widget. So we updated the toJSON here. So now this goes through and finds all the accessories for this widget and opens them up, calls toJSON on them, which generates that dynamic object for us, and pushes them into, in this case, our array property here. And so those are all included in our dynamic object that we then convert to JSON and ship back to the server. So you start to get a sense of this sort of model of doing things. So we're writing these utility methods on the data class because that's where we're doing the customization, and it lets us keep that out of our REST calls, and those can be more streamlined and won't get as convoluted with this sort of thing. So I mentioned we pulled the controller class out. We have this new page controller JavaScript. It's just doing the same get call here to our Widgets Direct REST CRIS and putting the data, so we haven't updated that. We did go in our view page and we added a line right here that says there are X compatible accessories. You could list all their properties or the ones you cared about here. They're all in the JSON, but in this case we're just going to say there's 4 of them or there's 5 of them, whatever. So now if I go over here and refresh this, now we have this line that says there are 0 compatible accessories. If I reorder, this top one has 6 compatible accessories. So those accessories are now included in our JSON. Our Angular recognizes that and updates the view page to display that, or at least how many there are here. Okay. So we've got a great view page. It's displaying all the information we care about, but we want to make our website more interactive, and we want to actually be able to update this data. So we're going to write a set of CRUD calls in our REST routes. So create, retrieve, update, and delete. And these will each be a separate route, so a separate REST call. And you'll note a couple things. First of all, they're all using the same URL. These last 3 have a parameter included. The first 2 don't, so that is a distinguishing factor. The biggest thing that makes them different is this HTTP verb or method here. So get, post, put, and delete. Those are the 4. And that is what distinguishes them. So before we were calling http.get from the client. In the future, we might call .post or .put or .delete to get those other calls. And the cache server will just go through this route until it finds one that matches and then call that class method. So we're going to look at updating first. There are lots of discussions on the internet of put versus post. I believe put, I forget which way. One of them can be used for 2 things. We're just always going to use post for creation and put for updating. That separates them out, it makes the methods more distinct, and it's a clear delineation of what the route is for. And when you make that call, you include the data you want to save in the body of the request, and then we're going to write a utility method that will grab that and save it into our database. So we had a toJSON method, which took the data from our class, put it into a dynamic object, and then into a JSON. Now we're going to write from JSON to go the opposite direction. There is a similarly named system method, %fromJSON, which takes the JSON string that we sent back and converts it into a dynamic object. And then we're going to write a utility custom from JSON method that will take that dynamic object and save it to our class. We're going to be a little clever here. You can just grab the properties one by one like we did in the toJSON. We're going to write a loop that just iterates through all the properties in that dynamic object and checks them against our list of keys and saves them. So that way, if there is a property that doesn't exist for some reason, or properties that don't exist in our class but were included for some reason, it will just handle those without having a problem. And it'll be easier to update in the future. And then obviously we need our REST route to call this method, and we're going to have a put call that we'll call a update widget class method, which will do these from JSON things and update our database. Similarly, we can handle delete. We're not actually going to purge rows. We're just going to set a delete flag and then avoid those deleted widgets in our getAll call. So we'll update that SQL to say, where deleted equals 0. And we add a delete route for that HTTP verb delete, which will be a separate class method for that. And we'll have a widget controller that we're going to put this in. So we've been doing operations kind of on the page level. We've been doing a getAllWidgets call, which runs through our database, grabs all the widgets, ships them off. But we're going to start doing operations on a specific widget where we're going to be calling it with an ID. So we're going to separate those out into a separate controller, a separate Angular controller, to handle those specific to a widget operations. So we have a widget controller there, and we will also have a edit form, which I'll talk about more in a second, but that will be in an Angular template. So that was a bunch of slides. Now let's see what's changed. Stage 8. What changed in stage 8? Jump here. All right. Another thing we changed here is adding a map prefix. So this just sends everything that starts with /widget to a separate subclass. It's another way of separating out our code to make it easier to find things in the future. So we have our top-level REST dispatch class that handles everything coming into this CSP application. And now we've added this rest.widget class, which has all of our routes. So we've got our getAllWidgets, which is get with a blank URL. We have add a new widget, which is our post. And then we have the ones that are calling on an existing widget, get, update, and delete. We're going to look at the put one here. So this is called with an ID, and it's going to call update widget by ID. So we have the ID of the object here. This is known because when we initially grabbed all of them, we included the ID. So the server has a big array of widgets with the ID value there, and we're going to include that when we send it back. And pretty similar. We're going to create a dynamic object here, and this is just to return. It's kind of a good practice to always return something. But we're gonna open the widget by that ID. We're going to make sure it exists. And then we're going to grab the content of our request, which is the body of that HTTP request. And we're going to pass that string into our utility from JSON method on that widget object. So we have all the JSON, and we're passing that into our utility method on the object on the client side, on the server side. So now we have a from JSON method that calls the %from JSON. That's taking the JSON string and turning it into a dynamic object. And then we have this iterator loop that just grabs all the properties in that dynamic object, matches them against a key, which is the names of our properties, and saves that property. And that's pretty straightforward to save things. On the client side, Oh, right. So this is just setting up all the REST calls on the back end. I'll load the next commit, which adds an edit form. So we added two things here. We added the widget controller I mentioned. This has the operations specific to our widget. And we have an edit widget function, and we have a save widget function. And we have this template. So this is an Angular template. It just contains HTML inside. You will notice, again, we're using the material components to get that free styling. But this will just be injected into the page when we call the edit widget, which shows this dialog, and it's connected to our template module widget edit widget. So it shows this HTML code on our page. So these are the different fields. They're bound to a property in the controller. And name, description, all our different properties, and then we have a save button at the bottom that calls save widget. So that's these two. Edit widget is just showing that form, this edit form, and then save widget is calling our put method to our REST URL, and it includes this widget, which is the JSON object on the client side with that data that we ship back, unpack, and save into the database on our server side. So now I should be able to show you this. We haven't changed any of the data, but now if I click on this, we have an edit form here. And I'll change the price here to $13.12 and change the quantity to 1. And we'll save that. And then if we refresh, you can see the price was updated. So we did persist the data, and it was updated. Updated in the database, and it's loading it properly again in the view page. So we've got now we've got update working, we've got view, we've got update. You can do the same for delete, you can do the same for create. That just involves creating a new object in the database instead of opening an existing one. So we're going to improve our form a little bit, and I'm going to skip this one for time. But basically, we're going to use a few different material components that make it a dialog as opposed to a card. It just changes how it's viewed a little bit and makes it show up better. And then we're also going to wrap that template in a form, which will give us the free Angular validation. So we can mark certain fields as required, and then it will tell us these fields are required. It'll put a little star there. And if they're empty, the save button will be grayed out. So that's another feature of Angular you just kind of get for free, the same as filters or other things like that. So the newest development in Widgets Direct is that we bought out Worldwide Widgets, a competitor, and their widgets couldn't measure up to ours, and we've now incorporated them, and we're tasked with including those in our website. And I want to point out this is a separate class. It is cache, but it's a separate class, different property names, different table, different everything. Conceptually, it represents the same thing, but it's totally different. We can't just include it without any work. But because of the way we've set up these utility methods, we have an easy path to incorporate those things. So we're going to follow our same process. We're going to write a toJSON method to grab the data from that class, and we're going to just convert those properties on the fly to the same names that we were using from our original widgets class. And we're going to write a from JSON that saves them back. The one bit of cleverness here is that we're going to prepend the ID with a W just to differentiate them so that when we are saving a widget back, we know which table to go find it in. And we're going to update our getAll so that it has a separate cursor that goes through that other table. And then we're going to update our REST routes to include that. So let me jump back over here. Stage 11 is the updated form. Stage 12 has the Widgets Direct. All right, so we have this new WW widget class, worldwide widgets, and these are different property names. So instead of name, description, quantity, and price, we have widget name, summary, stock level, and cost. But in our toJSON, we're just going to convert those on the fly. So widget name becomes .name, summary becomes .description, and these names on the left are the same names that we've been using from our other class. So we just pipe the data into our existing kind of dynamic structure. And similarly, we write a from JSON that just saves those values based on the key. And we can go to our dispatch, our widget, and our getAll now has a second cursor that goes through that worldwide widget table and grabs all of those. Same deal, we open the widget, we call the toJSON on it, we push it into array, we write the whole thing to the client side. So all of this was just in our data classes. We haven't touched the front end at all. But when we do this, we now have worldwide widgets being included here. And the front end handles them all the same. They're in the same JSON array, and we've named all the properties the same. So all of the same fields on the front end map to the same property names in our JSON object, and it just works. And we didn't have to change our front end at all. It just we set ourselves up for success in this way. So I can do the same editing. This is the material dialog box. It looks a little different. And for example, if I remove this as a required field, I can't save it anymore. So there we go. We now incorporated a whole separate class into our page, and things seem to be working smoothly. We can filter on our widgets. We can reorder them if we want. You might notice that this is sorting them, treating this ID as a string. So you could tweak that a little bit to make it sort by as an integer if you wanted, so that 10 shows up after 9 instead of after 1. But that's a minor little thing. And so there we go. We've got our application's really coming together. Some enhancements you could do from here is add a new widget form. You could pretty much use that same template. You would just attach it to a new object. This, I think, is the next article in the series. Chris was out most of the summer, and I think this one is up now. And then you can also refactor the REST calls into a Angular factory as a way of encapsulating those in a separate file, so you don't have to have it just cleans up your code base on the client side and makes it, again, easier to maintain, all of that. So this is kind of my recipe for making Angular applications. This is what I want to be the big takeaway. And you'll notice I've kind of gone through this process. This is what Chris used in his series and his work. This is what I've used in a couple projects. This is what I used to mentor several interns this past summer. It's been very successful for all of us. So this is kind of my recommended, way of doing this. You start by configuring your CSP application. You've got your REST application, your REST dispatch class, and you can test a hello world call right there. And then we're going to start writing our toJSON method. So we write a toJSON on our data class, and we write a get REST call. And that REST call, you've seen it, but you open the object you care about. You call the object.toJSON to get a dynamic object with that data from the class. And then you write that dynamic object.%toJSON to ship it off as JSON to the client. At this point, you can test your REST call. You could write a unit test. REST methods tend to have a well-defined input and output, so you can write a unit test to test this sort of thing. There's also a RESTlet Chrome extension I'll show you in a second that I found to be very useful in testing at this point. And then from there, we've got our backend set up. We're going to jump to our front end. We're going to add or update our view page. And so we have a controller with a service that receives that that makes that REST call. So we're going to have $http.get with our get URL. And then we're going to have a some view form that binds the data we care about to the different fields there using the ng model or ng repeat, things like that, to create our structure. And we're going to use material components to get that nice look and feel without writing custom CSS. And then you can just repeat that, steps 2 through 4 to add additional properties, add additional classes, etc. And that's kind of how you handle the view part of it. And then for the edit, we just kind of do things in reverse. We write a from JSON, which grabs the JSON data, puts it into the % from JSON takes the JSON string, puts it into a dynamic object, and our from JSON method converts that dynamic object into, saves it into our persistent class. We write post, put, delete REST methods for all of those. Again, post we're going to use for create, put is for update, and delete is delete. And then on the front end, we're going to write a update or an edit form. We can use an Angular template for this so that it's repeatable and we can load it in wherever we need. It also separates out that code that actually interacts with the widgets or the whatever your class is. We bind the inputs same as the view, but we make them writable fields instead of just read-only. If it's a create, we may need to push that new object into our array of data on the client side, and then we call we make our REST call. We can make our update call or whatever you need, and then again you can repeat this for your to add properties, to add classes, things like that. So it's an iterative process. It gives you a way of building up your application from a base level, gives you points to test throughout. And I found it to be, pretty reliable. So, some resources: the article series on the dev community, Let's Write Angular 1x app. If you search that, you'll find it. The cache documentation on REST talks about that dispatch class and how to write your routes and the attributes you can use there. That's been very helpful. There is some great Angular documentation. I prefer the W3 schools. I think it's a little easier to navigate through and read, but there is also an official one. They both, they have all the same information. I just like the formatting a little better. There is a AngularJS from the material has a great documentation. It has examples of all the different components, what they look like, what the code looks like to implement them, and a link to a code pen so you can go try it out. And then this RESTlet Chrome extension is a tool that just lets you make these REST calls right from your browser, and you can check if you can make a call to your get and see if you're getting the right JSON object back, or you can even make a put call and include a sample JSON object to see if you actually saved it on the back end. So let me. You just put your URL in here. So if I do right, I think we put that in here. No? Well, all right, I must be doing something wrong. But you can use this to check those, to make those requests and check your output here. And if you're going to do a put request, you can include the body, so you can save a sample object or update an object, things like that. So this is a useful tool I found. Beyond that, pursuing development best practices. This is something you'll see in some of the other presentations. This is kind of a set of steps that we've been working on. There's different ways of viewing this, but it's a continuum of improving your development process and your testing process. And you can work on these as a ladder or as a series of improvements. I've mostly talked about the code and kind of touched on Git just a little bit to load the different versions in. The other presentations will kind of go up the rest of this ladder and show you other ways of doing this. So the Widgets Direct is on GitHub. It's a feature-complete sample application. We've got the material Angular REST JSON application that I've been showing you here. We've got %installer classes. There should be a Docker manifest to do that. %unit test logic for automatic testing, continuous integration. It should all be kind of a full package there that you can download and check. You can find it there. I don't know if the repo is public lit yet. It will be at some point if it's not. And there's a post on the developer community about this Widgets Direct application. So those other sessions, the first one is mine on AngularJSON and REST. There's a shared development in the 21st century tomorrow. This talks more about source control with Atelier. There's one on the %installer, %unit tests, and continuous integration. And then there's 3 on containers and Docker and how to use that. And these will all be using the same Widgets Direct application to kind of give you a common thread as they're demoing these different features so that you have something to follow along with and look at yourself later. I used Atelier here. There are a couple other Atelier sessions that I wanted to mention. One actually happened right now. There's one happening in 15 minutes on source control in Atelier. And then there's one Wednesday for web development specifically. And there's a survey in the event app that you can fill out. And the recording for this will be on the online learning site. And you can visit the Tech Exchange to learn more. I think there's an open house going on tonight. I know I'll be there, and lots of other people will be there if you want to ask questions. So thank you for your attention. And I have a couple minutes for questions. There are some changes, like the refactoring into a factory, and that make it easier to migrate. But they're not compatible. Angular 1 and 2 are not compatible. So it's something we may look at in the future, but it's not planned. I'm told people should use the mic if you want to ask questions so that it gets on the recording. But if anyone else has questions, I'll take those for a few minutes.